Hello, everyone. Hope you're having a wonderful day. We have a great presentation today by the one and only Alik Sokolov. So, Alik is the co founder of and CEO of SR.ai. His professional experience includes Deloitte Consulting as a machine learning team lead and product manager, and venture capital as an investor. He's also an accomplished researcher, having published works on applied deep learning to financial time series as well as for ESG investing. The latter set of algorithm is the backbone of SR.ai, used to extract and summarize ESG signals from unstructured data. Alex's talk today is titled Deep Learning for ESG, Advances and Limitation. As a quick reminder to the audience, please, if you have any questions, post them in the chat, and at the end of the presentation, I'll make sure to ask them to Alec for you. So, without further ado, Alec, please, take it away.
Hi, everyone, and thanks for that introduction. It's very nice. So my talk today will focus actually on a couple of things mainly. So we'll spend some time talking about deep learning and specifically deep learning for natural language processing, some recent advances, what is changing, and ultimately what is staying the same, as well as how this applies to ESG, so to environmental, social, and governance investing, and even more broadly to finance and asset management in general. As far as machine learning in recent years, let's quickly start by talking about some advances as well as some things that largely are remaining the same despite natural language processing improving. And in a moment, we'll dig into specifically what these advances are and hopefully together build some better intuition for why algorithms are working better in some ways and have some limitations in other ways. As far as natural language processing goes, since about 2017 has been a very, very exciting time for NLP. In 2017, Baswani et al. Came out with a paper called Attention is All You Need, which essentially changed neural network architectures that people use for deep learning and allowed us to later on use these architectures to build some very, very interesting models that were fundamentally different from how NLP was done in the past. These include BERT by Google in 2018, more recently GPT-2 and GPT-3. All of these models share between themselves the ability and to do transfer learning and take an advantage of transfer learning. And we'll talk in a moment what transfer learning means in the context of these language models. Of course, the availability of computational resources is increasing. Right. So, for example, BERT, that used to take days to train, in 2020 was trained by Microsoft DeepSpeed in 1 hour. Of course, this involves a lot of parallelization, a lot of machines being spun up at the same time. But of course, you know that the trend is for cheaper and cheaper computation. And this has two effects. This makes models like BERT, for example, from 2018, which is very, very powerful, much more accessible. And at the same time, allows researchers to scale up these models to be bigger and bigger and bigger, which in some ways makes them much more impressive. And of course, there are advancements in frameworks, meaning programming frameworks, right? So for example, PyTorch is the Facebook deep learning framework. It's constantly under development. Every year, it's becoming easier and easier to use, which also has a way of democratizing deep learning, making deep learning easier to do. There used to be a computing bottleneck or a programming bottleneck to doing deep learning where, early versions of TensorFlow, for example, the Google framework that was kind of first to market, were very difficult to use, and it took some engineering skill or knowledge. That barrier is becoming lesser and lesser over the years. Interestingly, though, some things in deep learning and in NLP and more machine learning more broadly are still staying the same. So one of them is the reliance on labeled data. When we speak about NLP specifically, this concept is a bit subtle. As we'll see in a second, one thing that language models have become much better off is take advantage of unstructured language data that exists. We as humans have written a lot of stuff over the years, and it turns out that the stuff that we've written and is just lying around there is a very good way to pre-train natural language processing models. However, it still so happens that to solve specific business tasks, we need to go through a process called fine-tuning, where we take a large language model that was pre-trained on text data that's just lying around there, and fine-tune it using some data that we ourselves have generated. that process is a big part of natural language processing in industry. And it's important to understand and important to have a process around how to do that most efficiently and how to evaluate how well it's working, etc. Because of all these things, there is a very important human element to machine learning, deep learning, and NLP that isn't going away as models get more and more sophisticated. Meaning that humans are required to design the tasks that models are solving in order to evaluate how well they're working and to understand how to sequence these different models to do the things we need to do. Because the kitchen sink approach where we just have one big model do everything doesn't always work out. And we'll look at some examples of that as well. And of course, AI is still task-based. I'm sure for those attending TMLS, you've heard this over and over and over. There is no general intelligence yet. There probably won't be in the near future. But interestingly enough, that's where we as machine learning practitioners, especially in the field of finance, need to know how to draw the line between what AI can do for us, what is still task-based AI, what can be framed as a well-defined task that machine learning models can be optimized around, and what is really in that AGI domain that isn't practical to do in a single model or a single hub. So let's dig a little bit into the actual advancements that happened. So I mentioned Waswani, this paper came out in 2017. Before 2017, it was common to either not use deep learning at all for natural language processing or use recurrent networks called LSTMs, long short-term memory networks. As LSTMs were being improved, people figured out they could use a mechanism called attention to essentially solve some technical problems that LSTMs had with losing memory over long sequences of text, for example. In 2017, Waswani et al. Figured out that they could do away with this recurrent nature altogether and build transformer networks that fully relied on this attention mechanism called self-attention. There was no recurrence at all. The advantage of doing this is compared to recurrent nets, these networks could be much, much better parallelized than GPU. Because of that, these models could be scaled to be much larger. They look at the entire sequence at the same time, so they don't have the memory issues that LSTMs have. And so for that reason, these networks became the state of the art for pretty much everything in NLP. When Waswani wrote their paper, they were looking at machine translation. But very shortly after, a Google paper came out that changed everything. That Google paper is BERT. I'm sure many of you in the audience are familiar with it. But I think what's instructive in the context of the talk is to take a look at what BERT actually changed compared to Waswani's paper. If you read the paper, there were two main innovations. One is the bidirectional nature of it, that's in the name. Essentially, the machine translation work that Waswani did used a masking procedure where as you're trying to translate a sentence, you're only attending to the tokens that come before the word that you're currently at in that sequence that you're trying to reconstruct. It turns out that that kind of one-directional constraint is unneeded and even could be a hindrance in general language tasks. And this comes down to the tasks that BERT used to pre-train the large language model that we all use today, or some version of which we all use today. So what were these tasks? So the first one is the mass language model task, which essentially is like playing a game of fill in the blank. And I'm not American, so I haven't done the SATs, but I believe something like this would be part of very normal language testing that humans do, where you're presented with a sentence, a word is masked, and you have to guess what is the word that's been removed, right? So for the example that the authors give in the paper is, my dog is hairy. The word hairy gets masked, and then the model needs to predict the word hairy is in that sentence. And then there is some denoising that they throw into the masking scheme, but that's more of an implementation detail. The other task is next sentence prediction, right? So you present two sentences to the model and say, does the second sentence follows the first, right? So the example here is the man went to the store and he bought a gallon of milk. That seems like it could be a next sentence, but a man went to the store and penguins are flightless birds is not a next sentence, right? This is nonsense. And the advantage of this pre-training scheme, it's unsupervised in the sense that we don't need to label data ourselves. But this very much looks like a supervised task. The great thing is we have this data just lying around. We can just take data from Wikipedia, from news articles, whatever, and take two sentences that are consecutive and shuffle them with random sentences for the second task. And likewise, it's very easy for us to create this fill in the blank task. So in a way, the unsupervised pre-training of BERT is that we're actually able to sort of hack the supervised learning and essentially an infinite amount of supervised labels. The miracle of doing all this is by playing those two games, it turns out that the model learns contextual embeddings of all the tokens that we feed into it that can then be used to do a whole range of tasks at the same time. That's why I say one embedding to rule them all. So because we have now this contextual embedding for every word, for example, it's very easy to do classification. We can just average those words, or we can keep a placeholder token called the classification token that we use in order to do classification, like classifying sentiment, classifying whether a sentence is sarcastic, right? Classifying ESG topics, and in our case. And at the same time, we can do some hacky things and, for example, try to say, okay, if we want to recognize companies, does this word look like the first word or the last word in a subsequence that could correspond to a company, right? Like Microsoft Inc. So we would try to read Microsoft as the first word and Inc. as the last word. And that way we can kind of hack the same model to do these multiple things. In the past, we had tailored models that did all of these different benchmarks separately. One model for name and entity recognition, one model for classification, one model for word piece things, etc. It turns out that BERT could do them all at the very same time, which is really nice because it saves us engineering time and allows us to share embeddings across different tasks. So these are the advantages. It's fairly obvious why this is better. One model instead of multiple models, you get better performance in all the things you're doing. You get to share embeddings between what you're doing. So because of transfer learning, as you do more stuff, using the same model, potentially it gets easier. These are all really good things. But what are some of the limitations associated with this? So an evolution of transformers is GPT-2 and GPT-3. For those of you guys not familiar, these are generative models. So these are also transformer-based models that have been scaled to be as ginormous as humanly possible in order to generate text. And the way you use GPT, or at least the most sort of basic use case of it, is you give it a writing prompt, which it then completes. I tested GPT-2 that Hugging Face makes available on some ESG-related tasks, right? So for example, I gave it prompts like Boeing's ESG performance this year has been, and it says exceptional, amazing, even outstanding. Boeing 737 MAX issues have been fixed, resolved. In 2019, Boeing 737 MAX issues have been solved, fixed. So what's happening here with these generative models is they're trained to generate sentences that look like English, that look like they're reasonable, that have coherence, that have good grammar, that sound like something someone would have said. What is missing here is a world model, meaning that the model doesn't really know what Boeing is. It might remember some things about Boeing because it knows the word or the token, but it doesn't really have an understanding of what ESG issues are, what main line of business are for Boeing, et cetera. And here's another example, right? So Boeing's major lines of business are in the high, the 777, the 777 end. Its revenues in 2018 were almost 20, estimated to be, or 16 billion, which as far as I can tell is a random guess. Or maybe it's, originating in some other sentence in a different context, who knows, right? And the 737 MAX is in service, a true super, an excellent end. Now, to be fair, maybe the implementation of GPT-2 that I have access to, the Hugging Face API, is limited in some way. As far as I know, it's the full model. Maybe this is not exactly a fair test. And I'm sure this can be done better. Of course, this can be improved with more data, with contextual fine-tuning, et cetera. We can make these models better. But in the most general sense, if our use case is something complex like ESG, is it feasible to have a general question answering system using something like GPT to solve all of our ESG issues? Probably not, right? That's what I would call the kitchen sink approach, where we just take one very, very large model, train it, try to do it, get it to do all of the things that we need to do and do it in one go. Arguably, or maybe not so arguably, probably most reasonable people would agree, in many domains, this is unfeasible. So what do we do? How do we go about this? So I would argue that the consequence of all of the things that we were just talking about, these advances in NLP, these limitations that still exist, are an evolution in the AI product management space, specifically for NLP and especially in the domain of finance. So we know that it's very important to pre-train unsupervised models. And we know that fine-tuning these models usually requires human-curated labels that are expensive and difficult to source. We know that there's a bottleneck in the implementation of these models. It's more difficult, it's computationally more intensive, it requires more infrastructure bottlenecks. It's difficult to rigorously backtest, right? For example, if you're in finance doing asset management, if you want to trade based on NLP signals, you probably want to backtest this rigorously, meaning that you worry about leaking future information. So you want to train the model on all the data available before one backtest, one part of the backtest, another, and another. This is very difficult, very computationally intensive. And I argue that all of these things require changes in the role of the AI product manager, right? So for example, for the previous backtesting question, really it's a matter of figuring out, is this a hard requirement? Can we live without it, right? Can we simplify our backtesting process, knowing that some of these particular issues probably don't change much over time? And we know that at least if we control the issues that we're using, we're not leaking. It's interesting that, this requires a kind of a specific mix of skill set, right? So, in traditional product management, a lot of the time, product managers are not engineers. And of course, you can do product managers for AI products as well by separating the two roles. But in my opinion, that does potentially create a lot of inefficiency. And so in finance, especially, the role of the AI product management that combines these two skill sets is very advantageous. So, and to wrap up, let's go through a case study to kind of summarize all this and hopefully put some context around this that will, give a nice real life example of why these things are important, how they work. And I'll talk about it from the perspective of ESG, what we do at SR.ai, what I'm sure many others are doing in finance in different domains. So let's first tackle a simple case study, right? So the very simplest thing that we can do with NLP is to use supervised classification in order to track different topics and measure how frequently they're occurring, right? So in the ESG domain, these are things like anti-competitive practices or mentions of climate change or data security issues. On the surface, this is very simple, right? So we just build a classification model, we source some labels, we fine-tune our model, we put it into production, and we're good to go. But there are some surprisingly subtle product management questions to be answered, even in this very simplistic case. Specifically, some of them are around the fact that when we build a classification model, our model doesn't spit out a prediction directly. It doesn't just say, this belongs to the anti-competitive practices class and this doesn't. It spits out a number between 0 and 1 that loosely corresponds to the probability or likelihood that this document belongs to this topic. And there's actually a very important trade-off here between precision and recall. We can tune our models by choosing the threshold to be very high recall and try to identify most mentions of risk. So for example, if we find that it's very important for us to identify all the mentions out there, we would prioritize high recall and have lower precision. Alternatively, if we find that it's very important for us to have low precision because our system is close to fully automated or fully automated, maybe we can live with lower recall. How to choose this is a question of the economics of the product. And it can become very disconnected if these economic questions sit separately from the folks who actually understand the technical work. Ideally, there's the same set of people, or at least some mechanism on a product team to combine both of these perspectives and do this in one go. Another interesting issue with classification, a lot of the time these labels are subjective, where your data might be not perfectly labeled. So even model evaluation sometimes doesn't get you all the way. And you need to combine that with things like eye tests and looking at, how well is this model behaving, even if it has similar loss or similar precision recall to an alternative model that might be in some other ways more poorly behaved and have some biases. And these can be subtle to identify. But it gets a lot more interesting and complicated if we look at something a little bit more involved than just pure classification. I think an interesting case study is the question of materiality. Materiality in the ESG domain is the question of how important or how financially material to a company's bottom line is any particular issue, right? So for example, environmental issues are maybe very, very material to energy and resources companies, and maybe less material in an industry like healthcare or infrastructure. At least according to SASB, what you're looking at is the SASB materiality map, which is a framework to try to help investors determine how material different issues are in different industries. It's very reasonable to ask from a product perspective, can we do this using AI, right? Can we do something more subtle, maybe more effective using AI? And what I'll give you guys is just a set of considerations that one needs to try to understand and set up kind of intermediate experiments for to try to decide how to actually do this. And again, this is the difficult thing in AI product management. So first, we need to decide if we're going to use rules or models, right? So maybe the right thing to do is just to use the SASB framework directly and not even go the machine learning approach. If we go the machine learning approach, we need to figure out, do we throw the kitchen sink at it like GPT, or do we do something more modular? Maybe it makes sense to split this problem out into some sub-problems that become much more task-based and aren't too much lifting for a single algorithm to do. Can AI even do this, right? Do we need a human in the loop? Like, do we need to take this as far as we can using algorithm and stop at some point and then let a human do this? And how do we measure success? Labels can be subjective. Again, this goes back to the previous one. So to summarize all this, I think these AI product management problems are especially interesting in finance. And there's a couple of reasons for why that's the case. World models in finance are incredibly important. Like we saw in GPT-2, algorithms don't really have these world models, but in finance, because you have so many more inputs than you have the ability to measure impact, the human world models come in to be very important. Finance was also the first to become quantitative, so in some ways it's slower to adapt these new advances in machine learning. But again, I would argue that at least in part, these product management lapses are to blame. And last but not least, in asset management, alpha is idiosyncratic and difficult to automate. And if you automate it, presumably that alpha will eventually go away. So again, it becomes very, very important from an AI product management and finance to delineate where algorithms end and where the human in the loop needs to begin. Thank you. So, if you're curious about more of these things about AI for ESG or in finance in general, please do reach out, visit our website, or shoot me an email directly. Always, looking to connect with more folks. Thank you for listening. I hope you found this informative.
Great. Thank you very much, Alik. This was very informative indeed. Very, very covered the entire evolution of NLP and how we can leverage it in finance, specifically for ESG. So I learned quite a lot in such a short time. Thank you for that.
Thank you.
Do we have any questions from the audience? I don't see any questions rolling in. If not, as Alik said, feel free to reach out to him directly after the call or whenever you have any questions. Could I reach out to you by LinkedIn? Is that okay, Alik?
Absolutely. Yeah. Also, great. Anyone here, feel free to add me on LinkedIn.
Excellent. I'll be sharing Alik's link to LinkedIn, so feel free to add him and reach out to him if you have some further questions. With that, thank you very much, Alik, again, and thanks to the audience for your participation. Wish you all a great rest of your day.
Thanks, everyone.
All righty. Take care.
Take care.